Well, this isn't the way the professionals do it. It's the way I do it. You wrap your socket with red tape. Sometimes I use yellow as well. So you go red or yellow, then black heat shrink, and then orange high voltage. And if you wear through one of them, you can see the other color. That's pretty obvious that you've got an issue. And then if you drop this wrench across those batteries, again there would be some issues. So this is what we're trying to guard. We know that it's going to happen. People, especially me, are clumsy, and it will happen. But we're trying to make it so it's not a capital offense, so you don't lose portions of your body or lose your sight or your hearing, burn yourself horribly if you make a mistake and drop something. So this is the red. This is not wide enough to go between terminals, but it'll be covered by heat shrink anyway with a little hole for the forward reverse. Just get the heat shrink done. Here we just got a little heat gun we use for, my wife uses for taking paint off of old furniture. Just get it as uniformly as you can. This heat shrink is about 2 to 1. It's a little bit big for this application, but and the wrench gets a little tasty. And then the socket is inside there. I'm going to put it down. Try not to knock the table. Cool off a little bit before we put it away. And then the black tape on top of that, because I didn't get the heat shrink up here, wasn't big enough. And then we'll cover it with orange. Just got some black tape in and around there. I should put some on the bottom here. And then we'll cover it all up with orange tape. And that'll be pretty much the extent of it. Again, we're just trying to guard against my inevitable clumsiness. Professional tools have a much thicker heat shrink, and it is actually designed to be electrically insulating, whereas this heat shrink is not. I'm just using it as a contrasting layer. If you see black through the orange tape, then you've had some damage, and take the thing out of service, get it redone. If you see red through, that means you've had some serious damage, and you need to modify what you're doing or how you're doing it, because you should never wear through the orange tape. Normal use, scuffing it on the bench and stuff, you will eventually do that, I guess. But with working around batteries and the electrical components, you should never wear through one layer of the tape. Wearing through 2 layers of tape is really bad, because you're getting close to no protection. getting close to a dangerous event. And actually hitting metal, seeing silver through through all the layers of tape means that you hit it pretty good. All right, I shall stop nattering. This is what it looks like when you're done. This is the socket, and here's the little M8 bolt that we're going to be using on the battery posts. And that's how I do it. I don't know how it should be done, but it's safer than nothing. We're going to be tightening up the posts, so I'm going to try not to be in the way. Just going to, I'm gripping this as tight as I can, as close to the handle, or close to the socket as I can, so that I don't over torque these. Strip them. There is a spec for the torque. It's 40 pound-inches or something. I don't have a torque wrench that actually goes that low. So what I started with is these things being finger tight. And each of them takes a turn and a half. This is my newly rubberized or newly taped ratchet. It's nice and snug. Before I start running silly amounts of current through them, these batteries will apparently do 10C. 10C is 10 times 40 amps, which is 400 amps. Which is a fair bit of current for these little batteries. These straps will definitely handle it. I think that the bolts will handle it. And I'm pretty sure that everything that I've put together up here will handle 400 amps continuous, not 400 amps for 30 seconds. I'm expecting that this system, I should probably turn it over a bit. I'm expecting that this motor car will take 100 to 120 amps at cruising speed, which is 3C. It's a little high for this battery pack, but since the car isn't licensed yet in Canada, maybe a little while before it gets driven at a large rate of speed. And at that point, as you can see, there's room for at least 2 more packs of this size. The controller will run down to 24 volts, but it will run as high as 120. We can do 2 packs in series, maybe 3. The DC to DC converter, I think, tops out at about 96 volts or 100 volts. And I think that's the smallest thing in the system. The charger, of course, would have to be changed if you were going to go into that size. Okay, those are all torqued up about as high as I want them to be. I'm not going to be connecting the cables on either end yet because I don't have the charger set up yet. But that's kind of the idea. We have this in place. We're going to have the cabling cut, terminated. I'll train it, and we'll go on from there. Okay, this fuse might be a little bit easier to see the corrosion. It's been, as you see, it's very dull there. And there we are, nice and shiny. So, dull. And shiny. what we're going to be doing here is putting this fuse on this, and obviously not using that bolt, connecting up to the negative on the pack, because protecting the cables coming out against short circuit is probably the safest thing to do. This is a 300 amp slow blow fuse, so it will take 30-40 seconds of 500 amps kind of thing before it blows. If it sees 1,000 amps, it's like 1/10 of a second.